Hey everybody, it's Dr. A here, and in this video we are going to be solving equation systems by substitution in yet another example. So this is the fourth example that I have a video for. And so in this particular example, our given information tells us to solve using substitution, and then it asks if the system is consistent or inconsistent. And so we have a system of two equations with two variables. We have x plus y equals 3. We can call this equation 1. And then we have x plus y equals 1. We can call this equation 2. And so we're going to go ahead and write solution. And remember, you want to write down all the steps nice and neat. Maybe use a ruler or a straight edge to help you stay organized and draw some lines nice and neat in your notebooks. Just as before, we are going to start with one of our two equations, and we're going to solve for one of the two variables in terms of the other variable. And again, as I've stated in some of my other videos, it doesn't matter which equation you start with, and it doesn't matter which variable you solve for in terms of the other one. You just you pick an equation and start with whichever one you would like to start with. So how about, just for kind of kicks and giggles, let's just start with equation 2 this time. So let's just say, let's start by solving for y in equation 2. Again, it doesn't matter. You'll get to the same conclusion no matter what. So equation 2, when I solve for y here, we're going to get y equals negative x plus 1. And then I'm going to substitute this into equation 1, okay? And so when I go to equation 1, what I'm going to end up with is x plus y, but now y is negative x plus 1 equals 3, okay? Now, if you take a look at this, what do you see happening here? You see that the x's will cancel themselves out, and you will end up with what? 1 equals 3. But this is not a true statement. What do I mean by that? Well, the number 1 is not equal to 3, right? So I'm going to write big here. 1 does not equal 3. These are two different numbers, okay? So what has happened here? Well, whenever you're using substitution, whenever you get a constant that is claiming to be equal to a different constant, then that is the indicator that your system has no solutions, okay? So we're going to say this system has no solution and is inconsistent. And we're going to make a note here that says when we have one constant equal, I'll put in parentheses equal because they're really not equal to another different constant, then there is no solution. Now, from the graphical perspective, if you were to graph or try to plot both of these equations on the same set of Cartesian axes, you would find that the graphs of these two equations would be a set of parallel lines. And hopefully you remember that parallel lines never intersect each other. They run parallel to each other forever, but they never intersect. And remember, from a graphical method, an intersection represents the solution to a system. So if you have parallel lines that thereby never intersect, then you have no solution to that system, and the system is inconsistent. So that concludes this short video example. Thanks for watching.